On the left of my screen, I have a parallel circuit. So parallel circuits are defined as circuits that have more than one path for the electric current to flow. So you can see the first path right here and the second path right here. And on the right, there's a series circuit, which is defined as a circuit containing only one path for electric current to flow. So if you go from one side of the battery, you can travel to the other side in one line, one path for the circuit to flow. So these two types of circuits are very different. For example, the current in series circuits is the same everywhere, meaning wherever you measure the current in a series circuit, it will always be the same number. So here, if we take our ammeter and measure here, it's 0.33 amps, and it stays the same wherever you measure all the way around the circuit. However, in parallel circuits, the current at the battery is the sum of the current in each branch. At each branch point, the current entering is the same as the current leaving. So if we measure the current from this side of the battery, it's 1.05 amps. But as we go to the different branches, it changes. But if we add 0.6 and 0.45, it equals 1.05. Another way these circuits vary is how we measure voltage. In a series circuit, the total of all the voltage measurements across bulbs must add up to the battery's voltage. This means that the voltage is equally divided between light bulbs if the resistors are the same. So to show this one, I just took out the resistors. So if we measure the voltage across the battery, it's 9 volts. But if we change it and instead measure the voltage across the light bulbs, it changes to 4.5 volts. And because there's no resistors, the measurement for both the bulbs, which is 4.5 for each, equals the total voltage, which is 9 volts. However, in a parallel circuit, each device has the voltage equal to that of the full battery voltage. This means that light bulbs will not get dimmer the more you add, which is why these light bulbs are brighter than these ones. So if we measure the voltage across the battery, it's 9 volts, and then across each light bulb, it stays the same. In our series circuit, total resistance is equal to the sum of the resistances, the multiple resistances in the circuit. So this resistor is at 2 ohms, and this resistor is also at 2 ohms. So the total resistance in this entire circuit would be 4 ohms. However, in a parallel circuit, measuring the resistance is what's most different from series circuits. So the total resistance in a parallel circuit is equal to the inverse of the sum of the inverse resistances. So you take the inverse of this resistance and the inverse of this resistance and add them together, and then that would equal the inverse resistance of the whole parallel circuit.
Okay, so here we have a parallel circuit. You can see the two different branches. So we have the total voltage across the battery, which is 24 volts, and we have one resistor that's set at 12 ohms and second resistor that's set at 8 ohms. So if we're solving for the velocity of the first branch and the velocity of the second branch and the total resistance, so because it's a parallel circuit, the velocity for the first branch and the velocity for the second branch would stay the same as the velocity across the original battery. So we automatically can skip those steps here, and we know that the velocity of 1 equals 24 volts and the velocity of 2 equals 24 volts. So to solve for the resistance, the total resistance, we use the equation 1 over resistance total equals the inverse of resistance 1 plus the inverse of resistance 2. So we have the inverse of the total resistance equals 1 over 12 ohms plus the inverse of 8 ohms, and then that would be 324 ohms, which is the same as 1 over 8. and we inverse that to get the answer. So our total resistance would equal 8 ohms. Okay, so here I have a regular series circuit, so the equations are going to be a little bit different. So we're going to be solving for the voltage over the first resistor and the voltage over the second resistor. And then we're also just going to do the total resistance. So to find the voltage for each of these, we go the voltage of one equals the current times the resistance. So that would equal 3 amps times 10 ohms. So the voltage over the first resistor would be 30 volts. And then to solve for the second one, we do the same thing, different numbers. 3 amps times 20 ohms. So the second voltage is 60 volts. And as we talked about earlier, those two add up to 90 volts, which equals the voltage across the battery. So, and then finally, we're just going to solve for the total resistance. And in a series circuit, you just add R1 and R2. So you'd 10 ohms plus 20 ohms. So the total resistance is 30 ohms. So a good real world example for a series circuit is Christmas lights. So when you unscrew one of these bulbs, the whole strand stops working because there's only one circuit. A good everyday example of a parallel circuit would be a light system with multiple lights. So as you can see here, I have 3 light switches or 3 light bulbs, and they're all connected to the same circuit, but they're all on different branches. So if you unscrew one of them, it goes out, but the other 2 stay on because they're in different branches. So a good real world example for a series circuit is Christmas lights. So when you unscrew one of these bulbs, the whole strand stops working because there's only one circuit